Last lecture I have taught you two methods of solving the simultaneous linear equations. Now next point in this chapter is determinant method of solving simultaneous linear equations. So what is meant by determinant? A determinant is a square array of numbers. So what is meant by square array? Square array is arrangement of numbers within pair of vertical columns, or we can say arrangement of numbers in the form of rows and columns. If A, B, C, D are any four numbers, then the representation of these four numbers in the form of columns and rows is called determinant of order 2, because it has two rows and two columns. That's why this is the determinant of order 2. And the value of this determinant A, B, C, D is AD minus BC, product of AD minus product of BC. Let us see how to find out the value of a determinant. So I have taken here some examples. Evaluate the following determinants. Here is one determinant of order 2 with these numbers 4, 3, 2, 7. So first of all, write down given determinant. 4 into 7 minus 3 into 2. This is the value of determinant. So 4 7s are 28 minus 3 2s are 6. 28 minus 6 equals to 22. It's very easy to find it out. Let us see one more example. Here is another determinant of order 2. 5 minus 2 minus 3, 1. So we have written the given 5 into 1 minus 2 into minus 3. So 5 ones are 5, minus 2 into minus 3 plus 6. So here is 5 minus 6. 5 minus 6, answer is minus 1. We'll take one more example. Here is the third example. Here is also determinant of order 2. 1 by 2 minus 2 by 3. 3 by 4 minus 4 by 5. So I have written here the given 1 by 2 into minus 4 by 5. 1 by 2 into minus 4 by 5 minus product of these two minus 2 by 3 into 3 by 4. So here we can simplify, dividing by 2, 2 ones are 2 twos are, we get the answer here minus 2 upon 5. Here 2 ones are 2 twos are 4, 3 and 3 gets cancelled, minus into minus plus 1 by 2. So we have to first of all equate the denominators. So by cross multiplying we get 2 into minus 2 minus 4 plus 5 ones are 5, and in the denominator 5 twos are 10. So minus 4 plus 5, 1 upon 10 is the value of determinant. Okay, let us see one more example. Here is another a determinant of order 2. 2 root 3 9 2 3 root 3. So I have written here the given 2 root 3 into 3 root 3. 2 root 3 into 3 root 3 minus 2 into 9. So 3 2s are 6. Root 3 into root 3 is 3. Minus 2 9s are 18. 6 3s are 18. Minus 18. This is 0. So I have given here some examples to solve. You solve this as a homework at home, and if you have any queries, then ask me. Okay. Now this is the method to find out the value of a determinant. Now how this determinant method is used to solve the simultaneous linear equations, and this method is called as a Cramer's rule. Okay, so this is Cramer's rule. What the Cramer's rule is? The method of obtaining solution of simultaneous equations by using determinants is known as Cramer's rule. Okay, so suppose here is a pair of linear equations a1x plus b1y equals to c1, a2x plus b2y equals to c2. So here a1 b1 c1, a2 b2 c2, these are real numbers and xy are the variables. So these are the two linear equations in two variables, or these are simultaneous linear equations. If we have to find out the values of x and y by determinant method, we have to find out the values of three determinants. First is d. How to find out the determinant d? We have to take coefficients of x and coefficients of y, a1 b1 a2 b2, which forms a determinant of order 2. Then second determinant we have to find out is dx. So when we find out dx, we have to replace these coefficients of x by the constant terms. So we get another determinant of order 2, c1 b1 c2 b2. And third determinant that we have to find out is dy. So when we have to find out dy, we have to replace these two coefficients of y by the constant terms, and we get here the determinant of order 2 a1 c1 a2 c2. When we solve these, then to find out value of x, we have to take dx upon d, and to find out the value of y, we have to take dy upon d. Let us see with an example. Suppose here is a pair of linear equations, or we can say these are simultaneous linear equations. Y plus 2x minus 19 equals to 0. So you have to transpose this constant term to the next side. So we get the equation 2x plus y equals to 19. This is equation number 1. 2x minus 3y plus 3 equals to 0. So 2x minus 3y equals to minus 3, as we have transposed these 3 to next side, and here we get the equation number 2. So by Cramer's rule, first of all we have to find out d. To find out d, we have to take the coefficients of x and y, and we get here a determinant of order 2, 2, 1, 2, minus 3. Okay, so 2 into minus 3 minus 1 into 2. 2 into minus 3 is minus 6, minus 1 into 2 is minus 2, minus 6 minus 2 minus 8. Now we have to find out the next determinant, that is dx. To find out dx, we have to replace these coefficients of x by constant term. So we get another determinant of order 2, 19, 1, minus 3, minus 3. 19 into minus 3 minus 1 into minus 3. 19 into minus 3 is minus 57, and minus 1 into minus 3 is plus 3. Minus 57 plus 3 equals to minus 54. And third determinant that we have to find out is dy. So we get another determinant of order 2, 2, 19, 2, minus 3. 2 into minus 3 minus 19 into 2. So 2 3s are 6. Minus 6 minus 38 equals to minus 44. So we get here three determinants, d, dx, dy. To find out value of x, we take the division of dx and d. X equals to dx upon d. So minus 54 upon minus 8. Minus sign gets cancelled here. X equals to, in simplified form, we have the value 27 upon 4. And to find out value of y, what we have to take? dy upon d. Minus 44 upon minus 8. Y equals to 11 upon 2. So here we have the solution, x 27 by 4 and y 11 by 2. Let us take one more example. Here is another pair of linear equations. 5x plus 3y equals to minus 11. This is equation number 1. And 2x plus 4y equals to minus 10, equation number 2. So by Cramer's rule, we have to find out three determinants. Out of that, first is d. So we have to take the coefficients of x and y to form this determinant of order 2. So 5, 3, 2, 4. These four numbers form a determinant d. 5 into 4 minus 3 into 2. 5 4s are 20 minus 6 equals to 14. Then next determinant that we have to find out is dx. So in case of dx, what we have to do? We have to eliminate or replace these coefficients of x by constant term. So we get a determinant minus 11 3 minus 10 4. Minus 11 into 4 minus 3 into minus 10. Minus 11 into 4 is minus 44, and minus 3 into minus 10 plus 30. Minus 44 plus 30 equals to minus 14. And now we have to find out the third determinant, that is dy, and for this we have to replace these coefficients of y by constant term, and we get here another determinant dy, 5 minus 11 to minus 10. 5 into minus 10 minus 11 into 2. 5 into minus 10 minus 50 plus 22, minus into minus plus. Minus 50 plus 22 minus 28. To find out the value of x, we have to take the division of dx and d. Dx upon d equals to minus 14 upon 14. X is minus 1. Y equals to dy upon d minus 20 upon 14. And y equals to minus 2. So here we have the solution x minus 1 y minus 2. So here is the worksheet. I'll send this to you. Solve all these examples by Cramer's rule.